thank you, fellow shareholders, for allowing me to spend the next few minutes hitting you with a few interesting ideas of innovation, especially as it pertains to McEwen. One key point here, there's a lot of problems in the mining industry. As we all know, the grades are getting lower, the costs are going up, issues with water and so forth. And there's lots of ideas out there. Every time you open a magazine, there's something about innovation this or IoT that or digital that. But where we fall down is the implementation stage. And I want to give you a few key examples of where we are succeeding in that area. I like this slide because it shows just looking at something differently gives you a totally new perspective on the issue. And we heard a bit about that from Javier. A lot of people looked at the leach pad residue in Mexico as a liability. But actually, the recoveries were about 65%. So 1/3 of everything we ever mined and blasted and moved and leached is still in the leach pad. So we're turning that into a value. We now have a way to get the gold out of that. Same thing, it was a liability from environmental perspective, but now we have a way of putting that into the tailings, putting the tailings into the San Diego pit. So just looking at that differently turns something from a liability into great value for us. Here's another way of looking at something differently. Every day, billions of people drive by a billboard, and someone took this and turned it into power, put it back on the grid. There's lots of examples. You know, people think that ideas come out of the ether like a bolt of lightning and hit people like James Dyson or Thomas Edison, but that's not true. Every day, all of us have great ideas. Some of them are great, some of them not so great. Not every great idea is out there, but there are a lot of good ideas. It's the implementation phase that helps us, that makes us fall behind. So here we have, if you're looking at a stockpile or a leach pad, you know, just look at it differently. You know, how can we get value out of that? It's not just the residual gold in there. It's not just the liability. Actually, in the back of the room, we have 3 people at the innovation table, and all 3 of them have something to do with the leach pads. We have people here with drones, so they're looking at it differently. They have visual inspections, they have thermal imaging, they have the LiDAR, so you know, take the opportunity to talk to them. We have someone here who's looking at bio-leaching, so you know, there are bugs and microbes out there that just love eating carbon, love eating sulfur, love eating silica. Whatever the issues we have in the ore, there are bugs that will do this for very low cost. We have people from Queen's University looking at sensors, so I'll talk a bit about that. So, you know, for drones, you know, it's easy to get them out there looking at the size of a pile or what it looks like. But, you know, we have the people from the University of Toronto working with us in Mexico on an online, in-time fragmentation that you can use for blasting or crushing. You know, we can use it for inspections, a lot safer and faster than having prisms around the mine. Hyperspectral, you can look at the grade of the ore from high up there. So there's a lot of great ideas out there. So here's the same picture, the way, you know, we would look at it versus the way a drone, versus the way AI, the way machine learning would look at it and tell us different things, the textures, the shapes, and so forth, as opposed to just the way, you know, the human eye can see it. We can't be afraid to look at other industries. So here's one from agriculture that, you know, somewhat similar to what we're looking at. So you could have a thermal image and you could tell which parts of the field need irrigation, which are under irrigated, which are perfectly irrigated. There's one on the right that's showing a weeding robot. So why not have a robot going and picking geochem samples? Why not have one going picking higher grade gold out of stockpiles? You know, people have these ideas, and the one in the middle is a copter drone spray. I'm not quite sure the application of mining, but I'm sure we can have a copter flying around picking up a high-grade nugget somewhere. The bio-leaching example. So, you know, we can't always afford to go with high-cost metallurgical processing, the cost of crushing and grinding and so forth. But the bugs love this stuff. If there's sulfur in the ore, if there's carbon in the ore, if there's nitrogen in the ore, these are all fuel for the bugs. So we have a few things on the go, and you can talk to Curtis from BioMine. By the way, Curtis was one of the finalists in the Disrupt Mining competition held at last year's PDAC event. So we're doing some work with him. So different bugs, different strains, you know, they'll attack differently. So You know, we have some samples from Tonkin on the go. We have some Palmerito samples, other samples in the portfolio. You know, so how do the bugs behave? What kind of recoveries can we get? You can do this in a heap. You know, some of these are done at low temperature, so you don't always have to go to low pH. Some of these are done at, you know, high pH. So there's a lot of advantages at looking at bioleaching. The last point is a lot of our operations are black box. For example, a heap leach, you know how much tons you placed, and sometimes you know the grade you put there, and then you get gold out at the back end. But you don't really know what's going on inside the heap leach. And we have a professor from Queens who we're working on some sensor development that allows us to look inside the heap. And he has a little demonstration here as well. So what happens if you could put some sensors inside the heap? And what happens if these are wireless? You don't have to hook up everything to you know, get them to surface. So what happens if you wanted to know the pH or the temperature or the cyanide or dissolved oxygen? These are all readily available. 10 years ago, this would have been a crazy idea. But now, you know, with the circuitry and the technology and the AI and so forth, you can know what's going on within your heap and optimize it. So, you know, why do we settle for 65% recovery? Why can't we push that higher and higher and, you know, get more with very little cost?